So you just take some randomly selected specimen of mangoes from the market, that is the training data, and make a table of all the physical characteristics of each mango. That is, characteristics means what we have. We have the color, we have the size, we have the shape, grown in which part of the country. This matters a lot. Mango grown in Bihar, in some part of Bihar, maybe taste different that with respect to some another mango that is being grown in some part of Assam, isn't it? And sold by which vendor? So these are the futures actually. And along with the sweetness, juiciness, ripeness, these mangoes have, and they can be considered as output variables. So we have training data, we have some futures, and as a whole, we will have some output variables. So you feed this data to the machine learning algorithm, and it learns a model of correlation between an average mango's physical characteristics and its quality. So that way, we'll build the model. So this is the training phase. Clear? Now we have testing phase. Say next time you visit or you go to shopping, and you will measure the characteristics of the mangoes which you are purchasing, that is the taste data, and feed it to the machine learning algorithm. And it will use this model which was computed earlier to predict if these mangoes that you are purchasing now are sweet or ripe or juicy. Clear? So what happens? This time you are collecting some new data, some new mangoes, and you try to test your model. You try to have some output from your model with respect to this new test data. And you can make your algorithm improve over time so that it will improve its accuracy as it gets trained and more training data. In simple words, I mean to say that when your training data are more, there is a means greater probability that you'll get more accurate result. Yes or no? So what happens if you have 100 data points, or I am considering as percentage. So that whole data set, which is 100%, then try to make 70% of them as training data and that rest 30% as the testing. Clear? So this is the training phase and the testing phase. I hope this concept is clear to you now. So let me ask you one simple question to you so that in that way I'll know that whether you are seriously attending this session or not. Okay, don't bother it. Just answer this question by options. And the question is, machine learning is a subset of artificial intelligence. First option says yes. Second option says no. So please answer your option, either A or B. I'm going to pause for 10 seconds. I'll have your answer, then I'll start. Well, 10 seconds over. So very good to see that all of you correctly answered this question. Obviously, machine learning is a subset of artificial intelligence. And question may come like that, whether DL is a subset of artificial intelligence. Obviously, in that case, the answer is yes. So thank you for answering these questions. So let's move ahead. Then the next topic I am going to discuss is the classification of machine learning, and this is very important. We actually classify machine learning into three different types. First one is supervised learning. Second one is unsupervised learning. And the third one is reinforcement learning. Well, let's talk about each of them in some examples. The first one is supervised machine learning. So from the term, it is very clear that supervision will be there in this case of in this type of machine learning. So this supervised learning is the types of machine learning in which machines are trained using well-level training data, and on the basis of that data, machines predict that output. You see that I'm keeping this level training data in red. So this means what? This level data will act a kind of supervision to train that model. And on the basis of that, machine will be trained and it will predict some output. So the level data means some input data is already tagged with the correct output. Here. So don't worry, I'm going to give you some examples. You can consider this strategy, this supervised machine learning, as similar to the teacher-student scenario. The teacher guides the student to learn from books and other materials. Nowadays, due to COVID-19, online materials plays the major part of this teaching learning process. So after that, the student will be tested, and if correct, the student passes. Else, the teacher tunes the student and makes the student learn from the mistakes that he or she had made in the test. And that is the basic principle of supervised learning, which means what? Learning from the mistakes, isn't it? So just tell me one thing. When you start learning the programming, any programming language, C, C++, in this case, Python. So what actually matters is the error that you will find in your program, isn't it? From the error, you will get to know that this statement will lead to some errors, and this error is of that type. And in that way, in future, you are not going to commit that same error. Or if you commit also, you can easily debug that. So you are trying to learn from your mistake in case of learning the programming language. Same principle applies here. So the basic principle of supervised learning is to learn from the mistakes. Now let me give you an interesting example. Suppose you have a niece who has just turned 2 years old and trying to learn, means trying to speak or learning to speak. Now, you want to teach her what a dog and a cat is. I hope you all know what a dog and what a cat. Consider this picture. Can you tell me this one is cat or this one is dog? I think this is dog and this is a cat. Correct? But that 2 year old, can she identify it? No. Only she can identify when you teach her, isn't it? So how to do that? Either you will show her videos of dogs and cats. This is one way. Or you bring a dog and a cat and show them to her in real life, so that pictures of cat and dog, so that she can understand how they are different. This is the two possible ways, isn't it? So if she is able to differentiate between dog and cat, you have successfully taught her. So here you are acting as a supervisor, and your niece acted as the algorithm that had to learn. Clear? So, sorry, making sure that she was learning the correct thing. This is the important, because in future, suppose she said that this is dog, so you are failed actually. You could not teach her correctly. So this is the principle of supervised learning. Now you got it. What is supervised learning? Let me define this mathematically. Means the definition of supervised learning with respect to mathematics. Supervised learning is the one where you have some input variables, say x, and an output variable y, and you are going to use an algorithm to learn the mapping function from the input to output. I hope you all know what is mapping. So this is the mathematical equation, y is equal to fx. So goal is to approximate this mapping function so well that whenever you get some new input data, that is x, the machine can easily predict the respective output variable y. Clear? So just when you try to learn machine learning in details, you'll find logistic regression and linear regression. There you'll see some equations. This type of equation plays an important part. Okay, so if possible in near future, I'll discuss some of these facts to you, and I already have some lectures on that. I'll give it to you after this session. Okay, links for that. So if I depict this concept of figure, then this is the clear one. Look at this figure carefully. You can take a screenshot of this one also. So see, labeled data. Labeled data means what? For each structure, for each this type of structure, we have some labels. Say this one, this is a hexagon, this one, this is a square, and this is a triangle. So these are labels already available for the data. So you will feed this, okay, to that model, and model will be trained. And what happened after that, when this model is being trained, after that you will provide some test data. Say these are the test data, and no tagging is there. Then if that model successfully predict that, yeah, this structure is a square, and yeah, this structure is a triangle, then only you can say that your supervised learning model works accurately, isn't it? That's how the supervised learning works. I hope this concept is clear to you now. Now, if I speak about the types of supervised learning, we have two major types: regression and classification. So regression is a kind of supervised learning. Again, classification is also a supervised learning. And believe me, in this is the most repeated question in every type of interviews, or your semester exams also, or some competitive exams also, that what is the difference between regression and classification? The difference is very clear. In one case, you'll get the output as some continuous or real values, like temperature prediction, age prediction, salary, price, sale prediction. Continuous or real values means what? You'll get the values like suppose 1, 2, 3, 4, or 30 degree, 35 degree, like that. There also you are taking the help of some statistical methods to predict those values from the past values, isn't it? So that is a regression technique, a kind of supervised learning. But in case of classification, you will get the output. The other techniques are same. Obviously, you are using some label data to perform the classification for the new data, and you will get the output as either yes or no, 0 or 1, the spam or not spam, cat or dog. Okay, so this type of classes will be known as, targets or labels. So this is the difference between regression and classification. I hope this is clear to you. So now coming to the next type, we have unsupervised machine learning. Now from the term itself, it is very clear that unsupervised means no supervision will be there. So you are not going to have some label data set here. Your model is going to work on some unlabeled data set and are allowed to act on that data without any supervision. So what will be the goal in this case? The goal is to find the underlying structure of the data set and group that data according to some similarities and represent that data set into a compressed format. Simply saying, if I want to define it in simple words, what actually unsupervised machine learning does, it will have some data set for which you don't have previous knowledge, and it will just divide the data set into different groups based on some similarities. Clear? So mathematically, this unsupervised learning is where you only have some input data, but with no corresponding output. So clear? So in this case, algorithms are left on their own to discover and return the interesting structure with respect to those data. And if I speak that how it works actually, so this figure is very clearly depicting that. See, in this case, these are the input raw data. See, they are cat, dog, you know that, but this is unlabeled data. No labeling is there. So this input unlabeled data will be interpreted, and based on some, homogeneity criteria. Homogeneity criteria means the similarities. They will be processed and they will be divided into different groups. Like in this case, two groups will be formed. One is for dogs and one is for cats. As you know, dogs will show some similar features, some similar properties. And similarly, cat will show some different features than dogs. So accordingly, you will have two different groups. So that's how unsupervised learning works. And if I speak about the types, then we have two types of unsupervised learning. One is clustering and another is association. And clustering means what? grouping the different objects based on some similarities so that particles or items belongs to one group will show high similarities, and while they particles or items belongs to different groups will show different or less similarities. Got it? I'm saying less also because in clustering also, if we go in details, we'll find two types of clustering like hard clustering, soft clustering. Okay, so there are lot of things to discuss, but yeah, this is not possible in this session. But obviously, if you want to know more, you can directly contact me. Now, clustering, you got it in simple fact that it is dividing the dataset into different groups, and each group is known as what? Cluster. And there we try to maintain two properties as high intra-cluster property and low inter-cluster property. Means, as I have said that particles belongs to one group, so high similarities, that is high intra-cluster property, and belonging to other group, they also have different properties, that is less inter-cluster property. Then association, again a kind of unsupervised learning. I have seen this question being repeatedly asked in competitive exam also. So what is actually association means what type of machine learning this technique is. So this is again an unsupervised learning technique. What happened? Here we try to form some rules, an association rule, which is used for finding the relationship between the variables in the large database. Actually tries to determine the items that occur together in the dataset. And this is frequently used in marketing strategy. Let me give you an example. Suppose a person is buying a bread, that there is a tendency that he may also purchase some butter or jam, isn't it? So they together, bread and this butter and jam, they together appear in that data set, isn't it? So if the shopkeeper keeps these items together, okay, so it means side by side, then there is a more tendency that those items will be sold more rapidly. So he got more profit, isn't it? Similarly, suppose you are going to buy milk, 1 liter of milk, and there is a high tendency that you are going to buy some eggs also, dozen of eggs also. So if you keep them together side by side, so there is a high tendency that the selling of this product will increase. So this example is a kind of market basket analysis. So that is association. Okay, one famous algorithm is a priori algorithm. And this is the different types. These are the different types of unsupervised learning. Now coming to the next one, that is reinforcement learning. And this is a kind of feedback-based machine learning technique. And here, an agent learns to behave in an environment by performing the actions and seeing the results of the actions. Now, in this case, some concepts of artificial intelligence are required to understand. Concepts means agent and environment. You know, in artificial intelligence, agent means those which are actually perceiving some information around its neighbors, and that is known as environment. Got it from this example? So this is agent. Some actions will perform by some agent, and based on that, if it is good action, it will be rewarded. That is it will get some positive feedback, and for each bad action, it will get some penalty or some negative feedback. So you can define reinforcement learning a type of machine learning method where an intelligent machine or intelligent agent, you can consider it as a program also, that interacts with the environment and learns to act within that. And one famous example in this case is the driverless car or self-driving cars by Waymo. I hope in the last sessions I have elaborated this in details. And game playing techniques also, you know, fear game that I have cited in the earlier session. That is also an example of reinforcement learning. The opponents always tries to learn from your tricks, from your strategy. Okay, so every time you need to change your strategy. So what happens? This way the game becomes more harder and harder. So this is one kind of feedback-based learning or reinforcement So these are the different types of learning. So just to check, don't mind it, just to check whether you have got it correctly or not, I'm again posing a question. And question is that regression is an unsupervised learning. You have two options. Option A, yes. Option B, no. So please type your answer. I'll pause for 10 seconds, then I'll start again. Guys, please give me your answers. Either type A or B. Sorry. Well, very good. I have almost got around 90% as correct answer. Yes, regression is not an unsupervised learning. Just reminding you that regression and classification are part of supervised learning. So our answer will be yes. Thank you for your answers. And well, this makes this session very interactive. So moving ahead, now I'm going to discuss this life cycle of machine learning. You can take a screenshot of this. So overall, we'll see 7 stages of machine learning in life cycle. Okay, the first stage is the gathering of data. Then second stage is the data preparation. And in the third stage, that is most important, that is the data wrangling. And in this stage, actually, we try to do what? Scaling of the data, or try to convert it to the correct format, try to remove those outliers. So actually, when you feed good data or feed the correct data, then the probability of getting accurate result will be increased. So this is very important, the start stage. Then you will analyze the data. Histogram analysis you can do, or different types of analyzing you have. So after that, after analyzing data, you will train the model, then you will test the model. These two stages are also very important. Obviously, this is the main part of the machine learning algorithm development. And then after testing, you will deploy them. So overall, these 7 stages constitute the life cycle of machine learning. I hope this is clear to you. Okay? So now, if you want to do some research or some experiments on those machine learning algorithms, so obviously you are going to need data. As I have cited here, that first stage is the gathering data. Yeah, you can collect your own real-time data, or you can have some standard data set from different sources. Here I am citing 3 different sources. First one is the Kaggle dataset, and this is the URL for downloading the same. Then second one is the UCI ML repository, and this is the most popular one, and this is the URL for that. And the third one is the AWS. Currently, it is being used by the researchers in this field. So I personally use the first two, Kaggle dataset and UCI machine learning repository. You will have enough data sets, different type of data sets to perform your experiments. Clear? Don't worry, I'll keep this link after this session so that you can go through it. So now I come to the final part of this session, that is the applications of machine learning. Well, we have different applications, but out of them, I'm going to cite some important ones. From this first figure, it is very clear what is actually going on. Face detection, isn't it? In Facebook also, you post your picture with some fans, and those fans will be detected automatically. Now this one is from self-driving car, and these are from these customers who bought these items also bought. These are from e-commerce site like Amazon, and this is the virtual assistant, isn't it? So let's discuss few of them. First one is the social media application of machine learning, that is the Facebook. And it is the most common application of machine learning, automatic friend tagging suggestions. Whenever you post a picture where 4 other persons are already there in that pic along with you, then Facebook will automatically detect them, tag them by giving you the option of automatic friend tagging suggestion. How it is possible? Because of deep phase. And this deep phase is a kind of deep learning project. Remember that deep learning I have defined as a sorry bunch of neural network. Bunch of neural network means what? It classifies that image on the basis of some several features. Okay, so this deep learning project, deep face, is the one actually responsible for this recognition of faces and identify which person is in the picture. Also, it provides the very good option, obviously, that is the alternative tag option. If some images are already there in the Facebook, then it may be tagged like this one. Isn't it? So this is very interesting application of machine learning in social media. Then other applications like video surveillance. You consider or you imagine a single person monitoring several or multiple video cameras. Then what happened? Obviously, this is a very difficult job to do and boring as well. How many monitors or how many screens you are going to monitor? So in this case, we need to take the help of machine learning. So means parallel monitoring of those different cameras. And with the help of this machine learning algorithm, here the computer vision plays the major part. What happens? We can detect or identify some bad activities also, some unusual behaviors also. An unusual behavior like, suppose a person standing motionless for a long time, or he is stumbling, suppose, or napping on benches. These things are considered as unusual behavior because as a normal person, are you going to do that? No. So this system can thus give an alert to those human attendants, which can ultimately help to identify or avoid those mishaps. And these reports are generated and counted to be true, and they have to improve the surveillance services. So one means after this 5 minutes, after 5 minutes, this session may be ended. Means after that you will be provided a new link or the same link in the group. You just click that and you can attend that. Okay, so don't worry. So that way, how machine learning algorithm can be used in video surveillance system. Then next application is the traffic alerts. I hope maximum of you have already used this. This is the Google Map. When you go to a place where you have no idea about that, then you'll use this map from your starting point to that destination point. You will just map it. You will take the help of this Google Map to reach that destination, isn't it? So Google Map is probably the app we use whenever we go out and require assistance in direction and traffic. And direction and traffic means we always try to follow the shortest route, and always we try to follow that route which has less traffic, isn't it? So the other day when you travel to another city and took the expressway, then the maps will automatically suggest you that despite the heavy traffic, you are on the fastest route. But how does it know? I hope you already faced this type of questions from the Google Map, isn't it? So this area has less traffic, or this area has means higher traffic than usual, isn't it? So the idea behind that is that some historic data or some historic data from the data actually Google is creating a massive database out of it. So it's a combination of people currently using this Google Map service and some historic data of that route collected over time and some few tricks acquired from other companies. So everyone using these maps is providing their location and the speed by which he or she is traveling and the route in which they are traveling. In turn, they will help Google to collect this massive data about the traffic, and this makes them predict the upcoming traffic and adjust your route accordingly. So that's the way how the Google Map works. That is the traffic alert, one application of machine learning. Clear? Then next one is the product recommendation, kind of machine learning application in e-marketing sites like Amazon. Suppose, consider an example, you check an item on Amazon, but you leave it, you don't buy it then. Okay, but next time or next day when you are watching videos on YouTube, you'll see that suddenly you an ad for the same item will be popping in front of you. Or you switch to Facebook, there also you'll see the same ad. Yes or no? You face it or not? Yes. So how this happen? Because Google tracks your search history and recommends ads based on your search history. And this is again one of the coolest applications from machine learning. And 35% of Amazon review actually is generated by this type of product recommendation. Sometimes while recommending the product, some discounts might be presented to you, might be given to you. So in that way, it sells products. That is one application of machine learning. Now, next one is the virtual personal assistant. I hope you all know this. This Siri, this Alexa, this Google Assistant, Cortana, isn't it? So as the name suggests, these assistants assist in finding useful information via text or voice. Suppose you want to search, where is my mathematics document? You can search like that. You can just give command voice command like that. Then Cortana will find that location where your file is located. So what happened? Different machine learning techniques like speech recognition, speech to text conversion, NLP, text to speech conversion. These techniques of machine learning is being used to develop this type of virtual assistants. Clear? Now, nowadays they become more popular. Like Alexa is very popular nowadays. So then we have self-driving cars. And in case of self-driving car, as you have seen that in the last session or last talk on artificial intelligence, I have cited the example of Waymo self-driving